Okay, here's 5.3, interpreting rate of change and slope. So our goal today is to talk about how do we look at rate of change and slope and what does it mean. So some things that I want you to remember, and you may want to write down, in fact you definitely should write down, rate of change is defined as the change in y over the change in x. One note that you may want to take specifically is change. I write that like this. That's a delta. That is, it looks like a triangle, but it means change. So change in y over change in x. I just want you to know that there will be times that I write it that way. So when we think about rate of change, we talked about it a little bit yesterday when we talked about linear versus nonlinear. So if I look at the rate of change in my table right here, it's not going to look constant, but let's look. In the first part, this is going up 1. And right here, it's increasing 0. If I was to find the rate of change, I'm going to abbreviate that ROC, I want to look at the change in x over the change in y. Oh, I'm sorry, I said that backwards. The change in y over the change in x. So my change in y is down here at the bottom. That's 0 over 1. Now, 0 divided by 1 is just 0. If you weren't sure, you could use your calculator. Let's compare and see what happens to the rest of the table. In this next section, my x increases by 2 and my y increases by 2. So for that portion right there, the rate of change is going to be change in y over the change in x, which is just 1. Notice that the rates of change here are different. All right, let's do one more section. The rate of change here is going up by 2 on the x, and on the y, if I count, that's up by 3. So here, my rate of change is 3 over 2. That doesn't simplify, I can't divide it, so I'm going to leave it just like that, 3 over 2. Last one. And this one, on my x, I'm going up 5. And my y, I'm going up 4. So my last rate of change in y, which is 4, over the change in x, which is 5. Again, like I mentioned before, these are all different. If the rates of change are different, then this specifically is an example of a non-linear relation. If all of the rates of change were the same, then this would have been linear. So this is nonlinear because we have different rates of change. If you were taking notes on this page, you should have written down the equation up here at the top, my equation about rate of change. You should probably copy the table down, including the different changes that I calculated for the different portions of the table. And then I would also maybe make a note that this was nonlinear because there are different rates of change for each portion of the table. When the rate of change is the same, so if rate of change is the same, that means it is going to be linear. And we have a special word for that, and it is slope. You have calculated slope many times before, so I'm just going to remind you of a few different equations. So the first equation, if we're given a table, the equation I want to use for slope, and this is a little strange, slope, they use the letter m. I think I told you once before that I don't know why they do that, but it does make us think about how it is moving. So from a table, m equals the change in y over the change in x, like what we just did. From ordered pairs, so ordered pair, remember, is when we have like x comma y. From an ordered pair, we have this kind of, it sounds a little weird, but it's not too bad. This formula that's y2 minus y1 over x2 minus x1. You should be familiar with that formula, but we'll talk about how to use it. Some notes that you should take, that you know x and y, the 1 refers to the first point, the 2 refers to the second point. We'll talk about that when we do an example. Then we need to know how to find it from a graph. So to calculate slope from a graph, this is probably what you're most familiar with, is this phrase rise over run. That just means that we're going to count up or down, either one, and then we will count left or right. And almost always we're going to be counting to the right. The last thing we have to talk about before we do some examples are types of slope. So if we just take a second to think about some basic graphs, remember all of these are supposed to be linear. If we're increasing, this is going to be a positive slope. And sometimes people are like, but this arrow is pointing down. Think about it if you write your name on it, right? If I write my name is going up. That indicates that that's a positive slope. The same way, this graph is going, if I write my name, it's going down. So this is going to be a negative slope. All right, then if I write my name across, that's the easiest way to write my name. So that's going to be a 0 slope. Think about the fact that that takes 0 effort. And if a line goes straight up and down, I can't even really write my name on that. That's very difficult to write my name on, LLI, right? So that's going to be what we call undefined. I actually once had a teacher that made me think about if you were to ride your bicycle, right? You can't ride your bicycle straight up a wall or straight down a cliff. I mean, you can, but that's not going to end very well. So because we can't ride our bicycle well up a cliff, that's going to be undefined. Okay, so let's practice trying to find slope in these different formats. So they want us to first describe the slope and then to find it. So if I describe the slope of my graph, if I was to write my name is going down, so I know this is a negative slope. And then they actually want me to give a value for it. So they're giving me 2 points. And when we have graphs, I think it's going to be easiest if we count rise over run. I'm going to zoom in for a second so that we can focus really on just this specific graph. Okay, so I want to count rise over run and think you want to start wherever your name started. So I'm going to start at this point up here. Notice that my graph is counting by 2s, so I'm actually going to count by 1s. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, I did rise first. So rise means you want to either go up or down. Since I had to go down, that means my rise here is negative, I think I said 14. Yeah, that should be right. And then it's over run, which means I'm going to either have to go left or right. So paying attention, this is 1, 2, 3. I went over 3, so my run is positive 3. Now, the only other thing you want to do is think about, is it possible for us to simplify that fraction? And it's not. There's nothing that goes into 14 and 3, so there is my slope there. Another way that you can check that you had that right, remember you said that it was negative slope, so it's a good thing that we got a negative answer. All right, on our table, we told ourselves before that we were going to do change in y over change in x, and they are trying to trick you. Remember, y is on the bottom here. So let's think about what's happening on our y section. We just want to pick one part of the table to focus on. So I'm just going to use these first 2 sets. So my change in y is going to be plus, that's not going up any, so I'm going to call that plus 0. So I'm going to put that on my top. On the x, I'm going up 1. 0 over 1, if you use a calculator or if you divide, that just gives you 0. So my slope is 0, so m is 0, and that is a 0 slope if we define it. That means if you plotted that table, it would give you a slope that looked like this. All right, last one is this set of ordered pairs down here. And I want us to remember there was a formula. It was m equals y2 minus y1, x2 minus x1. Remember, in every ordered pair, we have x comma y. The 1 and the 2 refer to the different points. So in this first ordered pair, I have x1 and y1. All right, I'm right here. This is my first ordered pair, x1, y1. Because the -8 is in my second ordered pair, I'm going to call that x2 and y2. And if you label, it's going to make it really quick for us to just plug in. So they're asking me, what is y2? And if I look, y2 is 2. Minus, what is y1? That's 5. Now if I look at my x's, what is x2? It's -8. Minus, what is x1? It's -3. Notice that I had to write a minus sign and then write the number -3 down here. So now this takes maybe just a minute to calculate, so I'm going to simplify the top. 2 minus 5 is -3. Simplify the bottom, and I would actually maybe take one step to write this out. This is -8 plus 3, which is going to be the same as -5. And the only other thing I want to do, if you notice here, you've got negative divided by negative, that is positive. So my slope is positive 3/5, which means here I would need to label that this is going to be a positive slope. So somehow my graph is going to be going up, and we'll talk more about that later. Last problem, we want to find and interpret the slope. So the things that maybe you would want to write down from this word problem, I would write down these points that are given to you, and then you may want to write down that it says the number of cubic feet in water, y. So y is the amount of water, and x is the amount of hours. So what they want us to do is find and interpret the slope. So to find the slope, they've given me ordered pairs, so we're going to do the same, y2 minus y1, x2 minus x1. I would, again, label your ordered pairs, so x1, y1, x2, y2. I'm going to take a minute to work this out. And when I did that, I got 50/1, which is the same thing as 50. Now, we want to interpret what that slope means. So I know the number is 50, but I want us to think about our variables and what they stand for. So in our equation, they said y stood for the cubic feet of water in the reservoir. So what this means is that my y up here, this 50, stands for 50 cubic feet. There are 50 cubic feet in the reservoir. And then after x hours, so the x down here stands for the number of hours. So there's 50 cubic feet in the reservoir every 1 hour. And this is flowing into the reservoir, so you want to think about that means they are adding, you are increasing or adding, I'll say increasing, you are increasing by 50 cubic feet of water in the reservoir every hour. That means that's how much is flowing in every single hour. So remember, I got that because I looked at what the variable stands for. So 50 I knew stood for feet of water, and the 1 stood for hours. All right. Here are our essential questions for the day, so make sure that you can answer these 3 questions. If not, you need to rewatch the video or plan to come into tutoring so that you can understand what parts you weren't getting from the video. See you tomorrow.